Okay, any question? Yeah, you can ask question.
It's important that how you're considering the phase. What is inside, not what the etching profile, how will it create inside?
Yeah, okay. Yeah, it's a good question. He's asking about there's a final structure, right? So how does the etching progress? During the etching, they may not falling into the final structure. They will have some intermediate structure. So we will talk about that later. They will be more complex. Sometimes we need to use a simulation tool to solve the structure. But for some simple structure, we can have a very rough idea. I give you a very rough idea. But the importance is the final structure because no matter how long you do the etching, the final structure will be exactly like this. Depends on the direction you look into. Okay? Okay, let's try to do it gradually because I have finished all the classes actually by using this crystal, but we will have some example to bring you into this field easier. Okay, so now we do it slower. Okay, now we give you some cases. Okay, before that we need to understand the crystal orientation. Okay, so for when you get the wafer, okay, the wafer is a single crystalline material from made of single crystalline materials. They have a different direction. So the most usual wafer we bought from the market is 111 wafer. When we talk about the wafer as 100 wafer. When we talk about 100 wafer, that means the surface of the wafer, the direction is a 100 direction. Okay, so when we talk about 100 direction wafer, you put the wafer here. So the relationship between the crystal and the wafer is look like this. Okay, so the 100 wafer actually there will be a big flat on the side. The direction of the big flat will be the 110 direction. Okay, so that means vertically this z direction is the 110 direction. The other 110 direction is 45 degrees to the 110 direction. Is on this direction. So you call this x-axis, is y-axis. The x-axis is 100 direction. Y-axis is also 100 direction. These two axes is a 45 degree to this 110 direction. Understand? Okay. Okay. So when we do etching, okay, on this silicon substrate, the final structure will stop at this full surface underneath. The full surface, the full 111 surface, they are the most slowest surface is the 111 surface. Okay, when you take a look down the surface and you do etching, no matter how long you go, finally they will stop at this full surface. This full surface are 111 surface, the slowest surface for etching. Just stop over there. So that's why no matter what kind of structure you put on top, and finally you will get a pyramid structure underneath if you etch time long enough. Okay, all the structure will stop at the 111 surface. Can you understand? So when we look from the 100 direction, okay, so the crystal look like this. So you etching down, you get a full 111 surface. Stop over there. Okay. So so that's the sense we built here. Okay. So the direction of the 110 direction is actually is vertical to this line. Right. So in this A-phase cubic, we have 12 lines. So 1, 2, 3, 4 on the top, and 1, 2, 3, 4 in the center, and 1, 2, 3, 4 at the bottom. So these 12 lines represent, okay, 12 110 surface. Okay, and we have 6 apex. So x-axis occupy 1, negative x the other one, positive y the third, negative y the fourth, positive z fifth, and negative z sixth. So we have 1, 2, 3, 4, 5, 6 apex. They corresponding to 6 100 surface. Okay, so finally 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom. The 4 111 surface on the top, 4 111 surface on the bottom. In total, 8 surfaces. They are 111 surface, the slowest surface. That's the final structure. Okay. Okay. So when you take a one pyramid structure over here, okay, because a line, the distance is equal to each other for all the lines on this A-face cubic. So the pyramid here, you have the line, the length of the line are the same. So so these three are equal, the line width. So when you want to calculate the angle, this is a right triangle. So this angle will be 60 degrees, right? But the angle we are interested in is not this angle. The angle we are interested in is the angle inside this triangle. So this triangle, you can see the bottom line, the length is the same as this one, right? The length here is the same as the older lines are in the cubic. But this line is a little bit shorter than this one, right? Because this is from a triangle. So this line is shorter than your the lines of the A-face cubic, right? So you form another triangle here. Because the line here is shorter than this one, and the bottom one is the same as this one. So this angle must be smaller than 60 degrees. If you have a right triangle here, the angle here is 60 degrees, right? 60 degrees. So this angle will be shorter than 60 degrees, smaller. Okay, so when you do calculation, actually the length here is I think it's square 2 over 3. Sorry, square 2. Square 3 over 2. Square root 3 over 2. So the length of here is square 3 over 2. So you do some calculation, you can find out the angle here will be arctangent square 2, and is around 55 degrees. Okay, angle here is 55 degrees. So that's why every time when we do the etching on a 1O wafer, and we got a pyramid structure underneath, the structure, the surface to the plane surface, the angle between them will be 55 degrees, not 60 degrees, 55 degrees. It's not 45 degrees, it's not 60 degrees either. It's a 55 degrees. It's a fixed number. So that's why you want to generate 45 degree mirrors. It's not easy at all by using the Bachmann machining. Okay, it gives you a 55 degree angle. The surface and the one surface of the pyramid to the top surface, the angle between them will be 55 degrees. Okay? Okay. Okay. So so let's skip this one first. Yeah, it's too much detail. So now you understand. So the slowest surface is a 111 surface, okay? Because several reasons. The first reason, you need to take out one atom from the 111 surface. You need to deal with 3 bonds underneath. Okay, the bond strength is stronger than only 2 bonds for the 100 surface for the atoms. Okay. The second reason is the density. The atomic density for the 111 surface is much higher than the 100 surface. So in your homework, I will be asking about how to calculate the density. Yeah, from different orientation. So you will get some idea about the density. So now we consider we are using the 100 wafer. The 100 wafer means the surface is 10 direction. And you look into the 11 direction. 110 direction. On the top is the 10 direction. And you look into the 110 direction. That means, come here. So the surface is the 100 surface. You look into the 110 direction, the flat, the wafer flat. Okay? You look into the wafer flat. So the wafer flat toward you. So the wafer flat is 110 direction. Top is a 100 direction. Okay? 100, 110 toward you. Okay? So remember, the crystal will be face you in this kind of structure. So the line, you will look into the line, right? Okay, on the top you have an apex on the top. You look into the line. So the bottom structure will be a pyramid structure if you do the etching. Final structure will a pyramid structure. Okay, so now we punch a hole on the surface. Okay, so we take out one square area. The rest of the area, we have a mask on the top. Only the center part, we leave the open. So we do the etching, okay? So when you etching down, you will find out this kind of pyramid structure. This is top view. This is cross section. This is pyramid structure underneath. If you're etching for a long time. So here I will draw the progress of the etching for your reference. So this is a 100 direction, and the face you, this is a 111 direction facing you. Okay. So for all the etching, it will be better to draw the final structure first. Then you go back to go through the progress of the etching. For example, as we know, because we look into this direction, that means we look into this crystal orientation. So the final structure will be the 1, 2, 3, 4 phase. Okay, arranged the structure. So when you look into this structure, the final structure from the cross section will be these two surfaces. So these two surfaces, the final shape will like this. And you got the angle 55 degrees over here. This is the angle between one inclined surface to the top surface here. Between them, 55 degrees. Remember, I just mentioned how to do the calculation. The calculation is here. So we are talking about this surface and this surface. The angle here is 55 degrees. Remember, it's not 45, it's not 60. It's 55, okay? Let's come back here, okay? Okay, because this shape is your final shape. So during the etching progress, your intermediate shapes will not be over the final shape, right? It's logic. You cannot take more material than your final boundary, okay? So the progress will, okay, so when you have an etching contact with this surface, you first will etching down, right? Because these surfaces all are 100 surface, so the etching speed is the same. So this surface will further down to one level to this one, right? How about the boundary? Just as I mentioned, the etching progress will not be over the boundary. So when they first encounter with the boundary, the etching will stop at the boundary. So the center is easy to draw. You just draw a line below the orange line, right? But for the boundary, you cannot be over the boundary, so you need to the same as the boundary. Okay, so this is the first time, maybe after 1 minute etching, you got this structure. Okay, so you have a flat surface on the bottom, but your boundary has been confined by these two 1, 1, 1 surface. Okay, we use this kind of notation. That means the direction. This means the surface. This means the direction. Okay. So these two directions are 1, 1, 1 direction, 1, 1 surface direction. Okay. So be confined. Okay. So after 1 minute, you see these results. So the boundary will not be above, will not be over, beyond the final shape. Okay. So this is the first step. So after another minute, maybe you can find the top surface going down again to some kind of position here. But on the boundary, you still be confined by these two 1, 1 surface. So you end up will have the shape like this. It's after the second minute, for example. Okay. Then gradually will go down, and then go down, and then finally become apex here, and stops totally. Okay, understand? So this is the progress of your etching. Okay. So using two rule of thumb. The first one, if you have the same surface, the surface will go down at the same distance because the etching rate is the same. So this is a 100 surface. So you go down to another 100 surface, still 100 surface. The distance is the same. Etching rate is the same. But when you encounter the boundary, the shape need to be confined by the boundary, will not be beyond the boundary. Only two rules. Okay? Is it okay? Because we are going to do even harder things. Are you scared? Okay, this is a simple part actually. Okay, so you need to understand this first. Okay. So, but those things happen only when this surface, this full surface, originally we punched the hole, it's a rectangle hole. So you can see this full surface, and when we etching down, the 111 surface will appear gradually, right? Because your etching stop over there. So finally form the pyramid structure, like I drew over there. You step by step, okay? So if you don't etch until the end, you take out at some time point, you end up still will find a flat surface on the bottom. But you will have some confinement on the boundary. For example, if you take out there's the first minute, second minute, 3 minutes, 4 minutes, 5 minutes. If you finish at 5 minutes, you take out the second minute at 2 minutes. So end out, you'll find out the structure like this. So still have a flat surface here. Okay? The etching stops because you take out the substrate from the solution. Yeah, it's not etching anymore. So still you have a 111 here. But you have a 100 here. Okay? Still look into the 111 direction, 110 direction. Look into the 110 direction. Okay? So, if you have this structure confined by four surfaces, the four surfaces is just in parallel to your the 111 plane. Okay, in parallel 111 plane. So end up easily to form this pyramid structure. Okay. However, if you have a structure like this, okay, you have a 1, 2, 3. Okay, this four surface similar to this one, right? 1, 2, 3. You just extend, become longer. Okay. So if you have a longer, what will happen? Longer opening. This is a rectangle opening. So it's easy to form this structure underneath. However, if we extend this one, into a longer opening, what will happen? So if you look into this cross-section like this, but if you look into this cross-section similar to this one, however, because the button need to be confined by 4 111 surface, so it will become this structure extend into a longer structure, but it still need to keep the crystal orientation. So the final structure will be like this, like a V-groove change. So you have a 111 surface on these two sides. There are two 111 surfaces on the other side. The center point will be extended into a line over here. So you still have 4 111 surfaces to confine the final structure. How to draw? Okay. All those are 111 surface. Okay, 4 111 surface. So you have an extension of the center apex into a longer line. So you find a change. Okay, so when you look into this position and then this position, the final result is different. Okay, look into this position. The final structure. Well, like a groove, right? Like a V groove like this. But look into here. This line will be the intersection of this line. Okay, this is the final line. Okay, this line will not go further. So this one is different from this one. This is from 111 surface. This still kept 100 surface. It's different things. So your HN already stopped here. Will not go further when you look into this position. Okay, this is a first extension. Okay, now all the corners, okay, give the angle. So it's smaller than 90, it's more than 180 degrees. So it's kind of sharp angle over here. However, if you have a masking structure larger than 180 degrees, for example here, so here give a corner, okay. So the final result you expect is like you have a 1 plane here to form this structure here, right? However, the question is if two 111 plane they form together become the angle smaller than 90 degrees. For example, like 90 degrees here. So these two surfaces will protect the line over here without further etching. However, if you have a two 111 planes in contact with each other, and the line over here will be exposed to outside, like the line here exposed to outside. So this is a line is an extrusion exposed to outside. So you cannot tell what kind of angle of this line surface. So the corner will be attacked by the etchant. So there's no way to stop it. Okay. So once even you form these two structures beautifully over here, but the corner here, because it's exposed to outside, cannot be protected. So the corner will be attacked. Okay. So when the corner be attacked, okay, gradually this surface will become the other surface for the next step. That's top view. Okay. So these two surfaces will retreat to the other surface. Okay, that's these two surfaces. And as time progresses, these two surfaces are still extrusion to outside. Okay, so it cannot protect the surface very well. So it finally will be etched away until the final surface, the final 111 surface formed here. So this 111 surface will form very good structure with the other 3 111 surface to protect the final structure. So the final structure will be fixed without further progress. So the material on the top, okay, there's a membrane, okay. So we put a masking material on the outside and also this flat area. So underneath, the material, silicon material, will be taken away thoroughly. So you leave only a cantilever beam over here. This one, a cantilever beam over here. So on the cantilever beam, there's no material underneath. The material has been taken away during this process. Okay, so here give us a lesson. So if we have the 111 surface, they form the angle smaller than 180 degree. Okay, small angle. So the final structure will protect this line, no problem. However, if these two surfaces form a extrusion structure like this, the line over here will be exposed to outside. So corner attack will happen. Okay, to take out the material from here until all the material has gone, and they will stop at the final 111 surface, which form smaller angle with other 4 111 surfaces. So this issue we call the corner attack. Okay, so you have two surfaces larger than 180 degree. Is like extrusion things. Okay, so it cannot be protected. But if it's a concave, we have convex actually. Convex structure cannot be protected. For concave structure, the line can be protected, and the structure will remain. So for convex structure, okay, you will encounter corner attack problem. For concave structure, the line can be protected without the corner attack problem. Okay. So this is top view. So when you look into a cross section, we draw a line over here. So originally, after short etching, you still see 111 surface. However, you have a convex. You have convex corner here. So when the convex corner has been attacked and retreat into the new surface, so when you look into this new surface from the cross section, you will see the etchant will go from the boundary and into the inner part of the structure. So at the end of the process, all the bottom material has been removed, and the surface retreat back to the final 111 surface. So you got the empty things of the cantilever beam. There's no material underneath. Okay, so the cantilever will be connected on the boundary only. Okay, so it's a freestanding structures without support on the bottom. The support is only on the side. Okay, so this is a very important step to fabricate a cantilever beam in micromachining process. So you can put a lot of different kind of devices on the top of the cantilever for different purpose. Okay, for example, if you can put a thermal sensor. For thermal sensor, you can put the metal fins on the top to prevent the thermal conduction to the bottom material. So that means you can preserve a lot of heat on the top to make the sensor more sensitive to the environmental change. Okay? Yeah. And also we can use this to fabricate like an electrostatic actuator, because it's freestanding things, so it can move up and down. Okay? So we can use electrostatic force to move the up and down to make actuation. Or maybe we can use this as a cantilever beam as like a accelerometer. For accelerometer, if you have an acceleration or you have a force driven onto the plate, the deflection of the plate can be measured. Then you can understand how much acceleration, okay, driven onto the plate because it's movable. Okay, so this is important structure. Let me finish one last thing. Okay, before we stop. Okay, so we got a common sense. If we draw arbitrary structures, holes on the surface, what kind of final shape we can have? Actually, the answer is a steel pyramid-like structure because we stop at the 011 surface. Okay, for example, you have this kind of opening, so you will end out well, the structure underneath the mask will be retreated until they face the final 411 surface. Because this is a long structure, so we have a pyramid structure with an extension on this direction, the center part extension. So it's like a V group underneath. So the extrusion part, the convex part, will be retreated. The material underneath will be retreated all the way until they face the 111 surface, the final 111 surface. Okay, so easy way to draw is like this. So for example, I give a homework out, okay? So I want 1O wafer, okay? So I arbitrarily draw any kind of structure opening in the surface. What kind of final structure we'll have? So the final structure is very easy, okay? We just draw 4 parallel line to 110, okay? Because each parallel line to 110 means you have a 155-degree surface. You can find out the 111 plane. So you can draw 1, 2, 3, 4 boundary line. Those boundary lines are the 110 boundary lines. So when you incline 55 degrees, you find out the final 111 plane. Okay? No matter how you punch the hole, any kind of a hole. So you just need to draw 4 boundary line first. The 4 boundary line, remember, they are in parallel to 110 surface. Okay, so this one is 110 as well. 110, 110, 110, 110 as well. When they incline 55 degrees, you can find the 111 surface easily, right? From 110 surface, okay, you rotate 55 degrees. Sorry, not 55, it's 35 degrees actually. From this side, it's 35 degrees. Okay, you will end up find out the 111 plane. Okay, so first draw 4 110 lines. Okay, so this is the final shape you can get. Okay, let's stop here and for some discussion. Okay, I think it's enough for this hour. So after you understand this part, maybe we can go on.